Alright, today we're going to look at our goal. We're in Unit 6, and this is Goal 6. And we're going to talk about parts of similar triangles today. So we're looking at being able to recognize them, because if we can identify them, then we know the relationships, hopefully. And so we're going to look at a few different parts of similar triangles. So our first part that we talk about is our altitude, and altitude is your height of the triangle. So how tall the triangle is. Anytime we talk about altitude, it's perpendicular to the opposite side. So it goes from a vertex to its opposite side, and it's perpendicular. Again, we have 3 altitudes, but the altitude of one similar triangle is proportional with the altitude of the second similar triangle. There, so we see that AD, FJ are both altitudes. They're proportional to any of these sides of the triangle. There. The next part of a similar triangle is an angle bisector. So this again starts at the vertex, goes to the opposite side, and it cuts this angle in half. So this angle is congruent to this angle if the triangles are similar. And so then this part would also be a part equal to this part, and this part to this. So we get some more similar triangles when we use an angle bisector. So the angle bisectors are also proportional in two similar triangles. And the last one is a median, and the median goes from vertex to the opposite side, and it goes to the middle of the opposite side. So again, median is that middle. If you think of the road, and the median in the road is the center of the road. So it splits these sides in half, and it splits these sides in half. Not equal halves, so that really should have 2 lines on it. So here we see this is medians because we have this side is split in half and this side is split in half. So since those are medians, then the medians are proportional. So 12 over 8 equals x over 5. And again, we could do this a few ways. We could go 12 to x equals 8 to 5. As long as if I do median on top, I have to do median on the other side on top. All right, let's cross multiply. So 60 equals 8x, and then divide by 8. So x equals 7.5. Finding the value of x again, this is an altitude. So again, if I can recognize those, that tells me a lot. So altitudes are proportional in similar triangles, and we're told those triangles are similar. So we could do 9 over 21 equals 6 over x. A lot of times when we're doing this, it's easier just to reduce this fraction. So 3 goes in there 3 times, 3 goes in there 7 times, and then cross multiply. That's not necessarily necessary, but sometimes that makes it easier. So then we have 3x when we cross multiply equals 42, and then divide by 3. So x equals 14. We can use these to set up similar triangles in estimating distances. So Sanjay's arm is about 9 times longer than the distance between his eyes. He sights a statue across the park that is 10 feet wide. If the statue appears to move 4 widths when he switches eyes, estimates the distance from Sanjay's thumb to the statue. So he's holding his thumb out, closing an eye, covering up the statue with his thumb. And then switching and closing the other eye, and when he switches, it looks like the statue moves. So we have this is what's happening. Here's the distance between his eyes. We'll call that 1 because it's relating that with the distance between his eyes from his eyes to his thumb, which is 9 times whatever that distance is between his eyes. And we see this a lot. Our bodies are very proportional in how we're created, and that is pretty neat, some of the proportions that we see on there that God put into us. So we have 9, 1 is the length of this side, 9 is an altitude. Here's his thumb, and the distance from that to the statue is, we're going to call X, because that's what we're looking for. And remember, the statue is 10 feet wide, and it moves 4 times the length. So this length here would be 40, 4 times 10. So then we have 9 over X, so my altitudes will equal 1 over 40, and then cross multiply, and we get 360 X. So 360 feet from him to the statue. So, and you can do that one's the same thing, it's moving 5, but now he's 12 feet. The sailboat is, so it makes that distance a little higher. All right, and the last thing we're going to talk about are triangle angle bisectors. So this is before we were talking about similar triangles and then their parts. This is just in one triangle by itself. The angle bisector actually breaks the triangle into two similar triangles. So the sides that it breaks into apart to the opposite, or to the other side, is proportional to this side to this side. So we see that also angle bisectors divides a triangle into proportional parts. So we could do 15 over 9 equals X over 6. So I did whole side to whole side will equal part to part. And then again, I'm going to reduce, so 3 goes in there 5 times, 3 goes in here 3, and then cross multiply, so 30 equals 3x, and then divide by 3. So x equals 10. And last one, n over 5 equals 21 over 7, so kind of set this one up a little bit different. Can reduce that down to 3 over 1 and then cross multiply, so 1n equals 15. Alright, so your homework tonight is page 505 to 506, and it is 6 through 22 even, but not number 18. All right, thank you. Have a good day.